Question, how much of the Drake equation can we fill in / solve with what we know already? I don't think any of the variables. None of the variables. In fact, before we get into this article, we can run through that just to make sure I'm not accidentally misremembering something. And I know there's been like a few different adaptations of the Drake equation too. Let me pull up a picture of it really fast. I think Sarah Seeger came up with like a slight adaptation for like some other, variable or like a different thing that we could be aware of with a variable. But I think even then we might not know the exact kind of things. Oh, sorry. I forgot the one variable was the rate of star formation in the galaxy. I think we have an idea, like estimates of that. Sorry, I'm trying to pull up a good photo of this. Let's look at this one. That looks nice quality. Maybe giant caves there. That'd be so cool. There are active volcanoes on Venus. So I feel like something I love about Mars is that obviously there's huge volcanoes on Mars and other ones, but the lava tube caves made from those volcanoes and stuff and the lava, whatever, I think could be a really good place to look for life on Mars, whether that's past life or maybe even current life. We don't know until we go there and check it out. But that's an interesting spot to look for life, that those caves on Earth, the lava caves on Earth are full of so many different microbes and single-celled organisms and multi-celled ones and all of that. So it kind of makes me wonder if we did look, on a different planet, if we would find something similar in a similar environment or not. And so, yeah, I think that's so intriguing. But my brain, because I am just very interested in astrobiology, I always relate things to that. So my brain is like, I wonder if there could be life in those on Venus, but I kind of assume that they'd be like full of lava or, just not a great environment because it's still like an active planet with a bunch of lava and everything. Like there's active volcanoes on Venus right now. And we just learned about the active volcanoes on Venus earlier this year. Was that last year? Analyzing old Magellan data from the 90s and then a few other more recent things. Super exciting. Also, the clouds of Venus. Sorry, I'm just info dumping now, but the clouds of Venus are also a good place. A specific like altitude of Venus's atmosphere is a good place to also search for life, which is really cool and really exciting. Anyways, I'm obsessed with astrobiology. I'll have to look into the cave thing though. That sounds really cool. Whether or not there could be life, still interesting and awesome to know. So yeah, Mimith, I saw you asked how much of the Drake equation can we fill in / solve with what we know already. That's kind of my own qualm with the Drake equation too, because I've had people be like, oh yeah, Drake equation states this. I'm like, no, because in my opinion, we don't have the variables here. We don't have enough data. But yeah, so for the Drake equation, number of civilizations in the Milky Way galaxy with which communication might be possible. So trying to find intelligent life out there, and they're saying that is equal to the rate of formation of stars in the galaxy. I'm not 100% sure, but I assume we have a number for this, or at least a rough estimate. But I know we're still learning about star formation and rates of star formation. But, there might be like a pretty scientifically conclusive number for this. I would honestly have to Google that. I'm not 100% sure. But I think, we have a pretty good idea of this. The fraction of those stars with planetary systems, we are kind of scratching the surface still, in my opinion, of like finding exoplanets and stuff. But I think we have a pretty decent idea of like what types of stars can have exoplanets around them, and that exoplanets are pretty common. Like they're out there. They're out there. I think I'm forgetting the exact numbers, but don't quote me on this, but it's something along the lines of like 80% of the stars in our galaxy are red dwarfs. And on average, they have like 1.2 exoplanets orbiting them, meaning most red dwarf stars have more than one exoplanet around them. But even then, there's, I'm sure, a lot of exoplanets we haven't found orbiting around them and around other ones. There's a lot of unknown exoplanets out there. It's easier to see and find bigger ones because they block more light or have more of a gravitational effect on their host star. But I think we have good estimates for these. Number of planets per solar system with an environment suitable for life. This one, I don't want to say we have no idea about, but I'm going to say we kind of don't have an idea about this. We are at the very beginning, in my opinion, of trying to find not just exoplanets. The first exoplanet was discovered in 1990 and then like 92. And then, we're just more recently looking at exoplanet atmospheres with this, trying to see where it could be suitable for life. I think that's a really exciting part of astrobiology and planetary science and the overall space news stuff right now is looking for those exoplanets, which are, by the way, just planets orbiting any star besides our sun, looking for, Are there environments capable of harboring life? So TRAPPIST-1 you've maybe heard about because, there's a bunch of exoplanets, 7 exoplanets orbiting that, and it's around a red dwarf star. So we're just kind of learning, especially in the habitable zone of the red dwarf star, we're just kind of learning about how exoplanets are around red dwarf stars. I feel like we have a very small sample size. Like TRAPPIST-1 is just one system, but maybe we've looked at some exoplanet atmospheres of other ones and it's like, oh, they're all really, really hot or really brutal, horrible worlds. But even then, it's probably like, I don't know, like 100 or so, like a handful out of like the millions and millions of planets in our galaxy. That's not enough to like conclusively say, or even to be like, well, it seems like, because we just need more data. But with more space telescopes and more cool things going on, we'll be getting more data and kind of be able to fill this in. This is probably a lower number. I feel like we could kind of assume, or just from what we've looked at and the planetary systems we've checked out, maybe a bit of a lower number, might be more of a rare environment, but might also be kind of hard to know because maybe there's some watery moons outside of the habitable zone or around a planet and we haven't detected any exomoons yet. We haven't confirmed any yet. Maybe the moons are... Maybe it's not just a planet, right? This says planets. Maybe it's a moon that has a habitable environment and we haven't even detected it and we don't know. So I think it's hard to like conclusively say. And anyways, we just need more data for this. The fraction of suitable planets, all of this stuff we have no idea about. The fraction of suitable planets on which life actually appears, we only know of Earth. We haven't even done the Mars sample return mission to see if life could have been on Mars from that cool biosignature, potential biosignature. There's so much that we need to look into. And yeah, this one, like, we have no idea. I think so, Charmed Chaos. I feel like there has been updates and there has been like this one, I think this is an update, like talking not just the number of planets in a solar system, but like planets and moons in a solar system, but also just having like updated data and other things. Yeah. And just kind of like guesses. But my big thing here is that half of this equation we have literally no idea about. And even some of it we have like loose guesses and more data would help, right? But like half of this, like we have no idea. We have no idea. But I'll get to the rest of these in one moment once I catch up with chat. Maybe Charmed Chaos would be very small with what we know so far. But that could still be like, 4 intelligent civilizations in the galaxy or something. But also we just read a paper talking about like how far we might be able to communicate with like things if they're out there. Suitable for life's also a big question. Agreed, it is. DNA based, carbon based, are there other forms we haven't considered? Yeah, that's definitely a big part of astrobiology too, is like looking into life as we don't know it. Like, what are the boundaries and other weird ways that life could come together? Like, what if there is life without DNA? What if it doesn't have carbon and it's silicon or something else instead? What if it doesn't need water and it uses something else as a solvent or whatever? Like sulfuric acid in Venus's clouds, perhaps? We don't know. So yeah, that's definitely something that's being considered. Maybe not in the Drake equation necessarily. And not every astrobiologist, is like very like, oh, life as we don't know it. But I do love pointing that out on stream. And thank you for bringing that up as well. Because yeah, could be a lot of different things that we just have no idea about. But maybe it is also really, really, really rare. And we're super duper duper fortunate, which, kind of bolsters the argument of, hey, we need to take care of our planet. Our planet is the one place we know of that can harbor life. It's where we all originated and evolved over millions of years. And now we're here and, we need to take care of our planet and take care of each other and, enjoy our shared existence on this beautiful world that we're on and make sure we're, not ruining the atmosphere and are taking care of the plants and animals and each other also.
Subscriber from the Citadel.
Yeah. As soon as you evaluate some of those n variables, would not change others in the equation. Maybe a bit, yeah. Like, I feel like the variables can kind of like feed off of each other too. Like, if there are a lot of systems with planets and a lot of those it all kind of affects it, I guess. I don't know if I made sense there. Your math DLC didn't load properly upon waking. I get that. Absolutely. Like, how small could life be and still be intelligent? Also, welcome in, Blairs. I don't know. Like, how do we define intelligent life? I feel like even on Earth, like, defining life, for one, I think is we talk about that, and we talked about that last stream. Like, there's kind of an ongoing changing definition, and different scientists or organizations, like NASA and other space agencies might have kind of differing definitions of what life is. Like, is a virus life or not? From what I know, that's one of like the ongoing things, right? Yeah, defining life is hard. Defining intelligence, I think, could be even more hard. Like, is it, you know, working together as a group to achieve their goals? Is it having communication and a language? Like, are dolphins intelligent life? Are whales? Are apes and everything? Like, yeah, but yet we still think we're like more intelligent. Is it like making tools to achieve things? Is it making fire somehow? How do we kind of draw that line, and also draw that line, especially with something on like a totally different planet? Find other worlds that both had life, no longer have life on them, along with finding worlds that should be habitable but are not. Yeah, there's so much that goes into it. Agreed. And that's my big point with it, is like we don't know these things, but there's just like so much. Yeah, it is an interesting question. The other pieces of this, you know, the fraction of life-bearing planets on which intelligent life emerges. Like, okay, so we need to find planets with life. Where does life appear? Where is the intelligent life? And just because we haven't found it doesn't mean it doesn't exist, by the way. That's hard to prove. The fraction of those planets with intelligent life that develop interstellar communication on top of that, and then the length of time such civilizations release detectable signals into space. I don't even know if we would be releasing detectable signals into space necessarily. Maybe it depends exactly how far, and maybe these civilizations are just too far away from us. But yeah, I forgot the initial question, but yeah, the Drake equation, there's just, most of this is unknown, or like we're just kind of scratching the surface on that field of science. I think it's interesting as like a thought process of like what kind of things might have to go through it to know how many civilizations could be in a galaxy. But yeah, and then that's just one galaxy out of billions and billions and trillions out there.